Okay, welcome to the very last page here. Let's go ahead and get started. These two are just like the ones on the previous page. We take inverse sine of both sides. So theta is equal to, we got to find out when sine, inverse sine is -1/2, or inverse sine of -1/2. And that's going to be at 7 pi over 6 plus 2 pi k. And what's 11 pi over 6, I believe, plus 2 pi k. Done. And then this one right here, we're going to take inverse cosine of both sides. And theta is equal to the inverse cosine of square root of 3. But square root of 3 is bigger than 1. So this is square root of 3 is bigger than 1. So it is undefined. That means there are no solutions. Number 13. It's a slightly more complicated one. Not much though. What we got to do is we're going to multiply both sides by the reciprocal here, 4 over 1. So that would cancel out that, and that gives us cosine of theta is equal to a -1. Take inverse cosine of both sides, and cosine, nope, not cosine, and theta is equal to pi plus 2 pi k. And cosine is only -1 one time on the unit circle, so we just need to list it the once. And we're going to go ahead and say k is some integer. Okay, number 14. Divide both sides by 8. And so we get sine theta is equal to -1/2. Take the inverse sine of both sides. And we get theta is equal to, so when is sine -1/2? That's going to be 7 pi over 6 plus 2 pi k. And it's going to be, the other one is 11 pi over 6 plus 2 pi k. Theta is by itself, so we are done. Number 15. Let's start by getting the trig function by itself. So we are going to subtract 1 from both sides. So subtract 1. If I'm going to subtract 1 here, I'm going to get common denominators and make it 2 over 2. That way I can see that a 2 minus a 2 cancels out, leaving cosine of theta equals the square root of 2 over 2. Take inverse cosine of both sides again. And we get theta is pi over 4. And the other one should be in quadrant 4, so it should be 7 pi over 4. And those are both plus 2 pi k. Okay, this one, let's start by adding 4 to both sides. Plus 4, those cancel out. So sine theta is equal to 0. If you want to take inverse sine of both sides, sine is 0 twice on the unit circle. Once at 0 plus 2 pi k, and once at pi plus 2 pi k. This is a totally fine answer. There is one slightly more simplified answer. It only happens when sine or cosine is at 0. You could also write this as theta equals 0 plus pi k, or just pi k. And that's only because these are exactly pi apart, or these two are exactly pi apart, and they just repeat. So either one of those either one of those solutions is totally fine. Okay. A slightly more complicated one now is 17, down to the final 4. So let's start by getting the sine function by itself. So let's add 2 to both sides. So I'm going to be adding 4 over 2 to get common denominators. So negative 3 plus 4 is going to be positive 1 over 2 is equal to 1/2 sine theta over 3 plus 3 pi over 2. Multiply both sides by 2 over 1. So 1 is equal to sine of theta over 3 plus 3 pi over 2. Inverse sine of both sides. Take inverse sine of both sides. Inverse sine of positive 1 is going to be, it's going to be pi over 2. So we have pi over 2 plus 2 pi k, can't forget the 2 pi k, is equal to theta over 3 plus 3 pi over 2. Now we're going to subtract 3 pi over 2 from both sides. So minus 3 pi over 2 from both sides. These are already common denominators, so that works out for us. So that is going to end up making that a negative 2 plus 1 is going to be negative 2 over 2. So that's just going to be a negative pi plus 2 pi k equals theta over 3. Multiply both sides by 3. Oh, I need to make it those big parentheses. Got to multiply the whole side by 3. So those will cancel out, leaving theta is equal to 3 times a negative pi is negative 3 pi. 3 times a positive 2 pi k is plus 6 pi k. Three more. Start by adding 4. Bam. Bam. That gives us negative 8 sine theta over 3 plus 3 pi over 4 is equal to positive 4. Divide both sides by negative 8. Divide both sides by a negative 8. And that should give us negative 8 on this side cancels out. Sine of theta over 3 plus 3 pi over 4 is equal to 4 divided by negative 8 is a negative 1/2. Now it's our trig function's turn, so we will take the inverse sine of both sides, which leaves us with theta. Let's see, make sure I have enough room here. Leaves us with theta over 3 plus 3 pi over 4. Inverse sine of negative 1/2 is going to be 7 pi over 6 plus 2 pi k. And then we have, that's case 1, and then our other solution is going to be theta over 3 plus 3 pi over 4 is equal to The other one should be 11 pi over 6. Plus 2 pi k. So there's case 1 and case 2. So let's start on this one right here. Let's subtract 3 pi over 4 and subtract 3 pi over 4. So that side is just theta over 3. This side, collect like terms. I need to get these to common denominators, so I'm going to say that's going to be 12. So I'll double 6 to be 12 and double 7 to be 14. And I'll triple 4 to be 12. So that way I'll triple that to be 9 pi over 12. So 14 pi over 12 minus 9 pi over 12 is going to be 5 pi over 12 plus 2 pi k. And then we can multiply both sides by 3. And option number 1, or case number 1, is going to be, so that would be a 4. And so we would get 5 pi over 4. So 5 pi over 12 times 3 is 15 pi over 12, which reduces to 5 pi over 4 plus 6 pi k. That's solution number 1. And then we do the same thing for this one over here. We are going to subtract 3 pi over 4, subtract 3 pi over 4. So this gives us theta over 3 is equal to, again, common denominators, going to make that 22 over 12, and it'll make this 9 pi over 12. So 22 minus 9 is going to be 13 pi over 12 plus 2 pi k. And then at that point, we can multiply both sides by 3. So I get theta is equal to, again, 13 pi over 3 times 3 is 39 pi over 12, which would just reduce that to a 4. So I get 13 pi over 4 plus 6 pi over k. I did just notice that we just want this first interval. So gonna go through here and just jot these down real quick. That's the only one there. That should just be pi. That's our only solution. Theta equals pi. Forgot about the interval part. On this one, these two are going to be our only solution. B is 1. So our theta is equal to 7 pi over 6 and 11 pi over 6. Those are our solutions there. Same for this case here. Since B is 1, these are the only two solutions. Adding a full rotation takes us off of that interval. So we have theta equals pi over 4 and 7 pi over 4. And again, this one is just going to be 0. So theta is equal to 0 and pi. These are our interval solutions. This one's going to be a little bit more complicated because it adds a bunch. Negative 3 pi is definitely not on our interval. Negative 3 pi is not on our interval. Too small. If I add 6 pi to that, that makes it So negative 3 plus 6 makes it 3 pi, also too big. So this actually has no solutions. No solutions on the interval. And then number 18, 5 pi over 4, that's good. So we definitely want that one. 13 pi over 4 is way too big. And then adding 6 pi is definitely going to make it way too big. So our solution for this one should be just 5 pi over 4. That should be our only solution. And then two more, 19. This one looks ugly, but we'll just take it one step at a time. Start by subtracting 1 from both sides. To make this common denominator, I will subtract 5 over 5. So that should give us 3/5 tangent of negative 2 theta plus 3 pi over 2 is equal to, so that 5 cancels out that 5, leaving just the square root of 3 over 5. We can then multiply both sides by 5/3, giving us tangent is equal to, or tangent of negative 2 theta plus 3 pi over 2 is equal to, the 5's cancel out, square root of 3 over 3. Take the inverse tangent of both sides, and that gives us negative 2 theta plus 3 pi over 2 is equal to, the inverse tangent of square root of 3 over 3 should be pi over 6. And because it's tangent, we can just add pi k instead of 2 pi k and only do it once. Now we need to subtract 3 pi over 2. I'm going to get to common denominators with its like term here. So that's going to be triple it. So I'm going to subtract 9 pi over 6. So that gives us a negative 2 theta is equal to 1 minus 9 is a negative 8 pi over 6 plus pi k. If you want to reduce that fraction, you can. Since I already wrote it, I'm going to leave it there for just a second. And then we need to multiply both sides by a negative 1/2. So negative 1/2 times a negative 8 pi over 6. So that cancels out the negative. The 2 is going to reduce this 8 to a 4, giving us 4 pi over 6, which would reduce to 2 pi over 3. So we get 2 pi over 3 plus, and then that's just going to be a negative pi over 2k. It doesn't matter if this is positive or negative because we're going to be doing both. K could be a negative integer, so it doesn't really matter if that's positive or negative. So I'm just going to get rid of that negative. If you have minus pi over 2k, that's totally fine too. Doesn't make a difference in this particular case. So now we just need to find everything on the interval. 2 pi over 3 is definitely on the interval, so we are going to write that one down. 2 pi over 3. This is one of the weird cases where it doesn't give us the smallest one. I can actually subtract half a pi from this. So that's 4 pi over 6, so pi over 3 should also work. This is one of those weird cases. And then I can add, so let's get these common denominators just real quick here. So this is going to be 4 pi all over 6 plus 3 pi k. So what we want to do here is just add or subtract 3 pi and try and stay within our interval. So if I subtract 3, I get pi over 3. If I don't do anything, I get 4 pi over 6, which is 2 pi over 3. If I add 3, I get 7 pi over 6, and that's small enough. And then I add 3 again, I can get 10 pi over 6. 10 pi over 6 is still less than 12. 12 pi over 6 is the highest we want to go. So 10 pi over 6 reduces to 5 pi over 3. And that's it. Can't add any more. And I just realized I wrote into my next question. So we'll just partition that out a wee bit. Okay. Let's see. -2. If you wanted this to give you the smallest answer, we probably could have done the negative angle identity right here, but we did not. I think if we would have done that, it should have given us the smallest answer. So let's knock out this one, the last one. This is the longest of the videos. So we're going to add 2. That's going to give us 1/4 sine of negative theta plus 5 pi over 4 is equal to 0. This time I am going to use the negative angle identity, so I make sure I get the smallest possible angle. So I can bring this negative out, but if I'm factoring out a negative, I got to change that as well. So this is going to end up being negative 1/4 sine. Since sine is an odd function, we can just pluck the negative out. 4 theta minus 5 pi over 4 equals 0. So that was the negative angle identity. Negative angle identity. Divide both sides, or multiply both sides by -4. So that would go away. 0 times -4 is the same. So we get sine of 4 theta minus 5 pi over 4 is equal to 0. Inverse sine of both sides. Four pi minus 5 pi over 4 is equal to the inverse sine of 0 is going to be, it's going to happen at 0 plus 2 pi k. Or if we want to be a little bit better about it, we can just say 0 plus pi k. That is a special time. Whenever you have sine or cosine or 0, you can treat it like this. Add 5 pi over 4 to both sides. So add 5 pi over 4 to both sides. And we should get 4 theta is equal to 5 pi over 4 plus pi k. We cannot collect those terms. There's a k in there that stops us from collecting them. And then I'm going to multiply by the reciprocal. I like multiplying by 1/4 more than I like dividing by 4. It's just easier with the fractions, I think. So we get theta is equal to 5 pi over 16 plus pi over 4. We're going to make this 4 pi over 16. We're going to make them common denominators, 4 pi k. And we're going to have a long list of these guys to take care of. We need to stay under 32 pi over 16. That's our max. If we see that 5 pi is actually bigger than 4, so we can actually subtract 1. So our theta is going to be pi over 16. And then we have 5 pi over 16, 5 pi over 16. Plus another 4 is 9 pi over 16. Plus another 4 is 13 pi over 16. Plus another 4 is 17 pi over 16. Plus another 4 is 21 pi over 16. See, save the hardest one for last. Plus another 4, 25 pi over 16. Plus another 4, 29 pi over 16. Plus another 4 is too big. So there you go. There's all 8 solutions. All 8 solutions. And we kind of know it has 8 solutions, at most 8 solutions, because this is that's a 4, so you can double it. It's either going to have 4 solutions or 8 solutions, typically 8. Okay, that concludes all of the videos. I will get these uploaded to YouTube and posted on Canvas. Email me with any questions you might have, and we'll take a look at these tomorrow morning or afternoon, whenever you have my class.